Okay, this is a supplemental lecture on the topic of memory forensics. And basically, the first question I ask here is, why does it matter? Well, RAM is volatile, which means if you reboot, the contents are lost. If you power it off, the contents are lost. However, it can contain live evidence of attacks that are going on, and it can reveal fileless malware, which would be things running out of memory that do not have a file associated with them, or the file that started the malware deleted itself so that you couldn't see it. It could show active sessions or connections. Sometimes there could be data that is decrypted that you might be able to see. So, what can be found in memory that would be of interest to us? There could be running processes, there could be connection information. We could figure out what libraries or modules are being currently used by programs. There may be open and or deleted files. There could be credentials or security tokens stored in memory. There might be encryption keys stored in memory, and we might be able to find out a command history for a user or a process. So, some key memory artifacts on Unix and Linux would be the maps file, which is a layout of memory regions that can be found in /proc/ the numeric process ID. There can be environment variables. There can be file descriptors, and what a file descriptor is information about a file that is being written and or read on the system. We can get memory info about memory that is being used by the process. Now, on Windows, what I did was I made a table, and that table is going to have the Unix command or concept, and then it's going to tell me the closest equivalent. So finding out the command line that is running, I can get that with Git process or Win32 process on Windows. To look at the memory regions, I can use the VM map or Process Explorer. Again, Process Explorer is a part of the sysinternals suite of programs that are very handy in forensics. For the file descriptors are also called file handles. So Windows has a handle.exe that will tell you files that are open. We can look at the /net out of the proc directory to find out network connections. On Windows, we're going to use get-net TCP connection in PowerShell. For environment, we can use CIM, or to a limited extent, WMI on Windows. Memory info we can get out of the proc directory. Notice there's no process ID because this is memory on the entire machine. We can use RANMap on Windows to get the same type of information. Now then, memory acquisition is grabbing a chunk of memory, or possibly all the memory, and storing it somewhere so that it can be used in a forensic investigation and also be collected as evidence. This must be done on a live system. It requires elevated privileges, typically administrator or super user access. And there are a number of tools that you can use. If you're on Linux, you can use a command called Lime. If you're on Windows, WinPMEM, or pmemory for physical memory probably. On Mac OS, there is OSX pmem that will give you a collection of memory that is being used on the machine. There are analysis tools. There's something called Volatile or Volity. It is open source and will do memory analysis. There's one called Recall, spelled with a K instead of a C. It is open sourced. And then there's also the strings command, which is included on all Unix, Linux, Mac OS machines. And since it is useful, sysinternals actually has a string command that can be used exactly the same for Windows machines. So that was a quick lecture on memory forensics.